Hi, I'm Catherine Sedgwick, and for the Universe unit, my group decided to do our project on terraforming, so I'm presenting on behalf of Andre, Tiago, and Margarita. So the first time I ever heard about terraforming was actually on Doctor Who, and even though it's a science fiction show, his explanation of what terraforming is kind of accurate. So I'm going to show it just to kind of introduce you to this concept.
Oh, yes. Yes. Isn't this brilliant?
Is that the source? It's beautiful. What is it?
Terraforming. It's a third-generation terraforming device.
So are we suddenly in Kew Gardens?
Because that's what it does. All this, only bigger, much bigger. It's in a transit state. Producing all this must help keep it stable before the...
Stop! Hold your fire!
What is this? Some kind of trap?
You said you wanted this war over.
I want this war won!
You can't win. No one can. You don't even know why you're here. Your whole history, it's just Chinese whispers. Getting more distorted the more it's passed on. This is the source. This is what you're fighting over. A device to rejuvenate a planet's ecosystem. It's nothing mystical. It's from a laboratory, not some creator. It's a bubble of gases. A cocktail of stuff for accelerated evolution. Methane, hydrogen, ammonia, amino acids, proteins, nucleic acids. It's used to make barren planets habitable.
So, although we don't have anything as complicated as this sort of bubble of gases, his explanation of how terraforming would work is pretty true. So what exactly is terraforming? As we know it, it is simply transforming a planet in order to support human life. And that involves altering the atmosphere, the temperature, and the general ecosystem of a planet so that we can live on it. Now, why is this something we're looking into? Well, as our planet continues to grow, it becomes less habitable, especially as it's getting warmer through global warming. So we have to start looking elsewhere for a new home, but it's important that we be able to live there once we find a place. So where could we possibly live? Well, Mars is the #1 candidate because it had a previous Earth-like atmosphere in its past. It already has some amounts of nitrogen, carbon dioxide, and water, and although the amounts do differ, especially when it comes to nitrogen in Earth and Mars, and the amount of carbon dioxide, they are still there, and terraforming would change those amounts. The average surface temperature is also very different. Mars is a lot colder than Earth because it's a lot farther. But the rotation rate is, as you can see, very close to Earth, as well as the axial tilt. And the gravitational pull is 1/3 of Earth's, which would change things quite a bit, but it doesn't necessarily mean we can't live there. Another place would be the moon. So Russians announced last year that they plan to build a manned moon base. Now the benefit of this is that it's closer than Mars. It's a 3-day journey. And it gets twice the sunlight of Mars as well, so it's warmer. However, it's much smaller and lifeless than both Mars and the Earth. One way that's a good thing because it would involve less work and investment in order to build an atmosphere, but we're trying to find a place to go because the Earth is expanding so much, so that wouldn't really help all that much. We've also looked at Venus, but that's too close to the Sun with a temperature of 900 degrees Fahrenheit. And we've looked at Europa, which is a Jupiter moon, and Titan, which is a Saturn moon, but those are too far from the Sun. So how exactly would terraforming be done if not through a ball of gas like in that clip? Well, if we were to terraform Mars, one of the ways would involve setting up greenhouse gas factories, which would actually be a way of putting global warming to good use. because as the greenhouse gases are released into the air, just like on Earth, it would heat the planet and melt the ice caps and allow the water to run freely over the surface of the planet. But that's actually a good thing there because it's so cold. We also would need to have a way of growing plant life in order to increase the amount of oxygen in the air. Another method of heating the planet involves large orbital mirrors that would reflect sunlight back onto the surface and heat up the planet. Another way is propelling ammonia-based asteroids onto the surface, which would increase greenhouse gases and again heat it up. Now, in order to terraform the moon, that would involve bombarding the surface with water ice comets. Before they strike the surface, scientists would blow these comets apart, and the ice shards would glide around the moon's equator to give it some sort of atmosphere. Now, with more comets and pellets, the moon would begin to spin quicker to give it a 160-hour day cycle. Now, the problem, though, is you would need around 100 comets to bring water and carbon dioxide, and these comets would have to be as big as, like, Halley's Comet. And we'll still need nitrogen and genetically engineered plants in order to provide the oxygen, and the comets don't really help that. So this video kind of explains Mars's previous surface and its current one and what we would need to do in order to turn it into a place like Earth.
In some ways, Mars kind of sounds like a cool place to live, doesn't it? The red soil, the craters, the dormant volcanoes, seems pretty scenic. And if you chose the right real estate, you could use one of the Viking landers as like a lawn ornament or something. But of course, you'd have to be okay with temperatures around -60, an unbreathable atmosphere, and deadly doses of radiation, which for most people are kind of deal breakers. But technology can do some fantastic stuff. And scientists who study terraforming, the science of transforming a planet to support human life, have put a lot of thought into changing these things. Turns out, with a few centuries worth of effort, we might be able to make Mars habitable for humans. But I'm not going to lie to you, it would be really, really hard. A whole bunch of major things would have to change. Most importantly, Mars needs an Earth-like atmosphere. There are a few theories about how to create one, and they have a lot to do with the planet's history. In its younger days, about 4 billion years ago, Mars was actually pretty similar to Earth. It was warm and wet and had something of an atmosphere. That's because the Martian soil absorbed a lot of carbon dioxide and nitrogen that was floating around in the air. But then, active volcanoes recycled those materials by baking them out of the soil, so they could be absorbed again. The result of this was an atmosphere that mostly stayed put. Asteroids that kept hitting the planet helped out too, keeping it nice and warm. And back then, Mars had a magnetosphere, a planetary magnetic field that protected the atmosphere from being stripped away by solar winds. But then the planet cooled and lost its magnetosphere. There were fewer asteroid collisions and its volcanoes stopped erupting. Without all that help, Mars's surface absorbed a lot of the compounds from its atmosphere and lost most of what was left to solar winds, leaving a freezing, dry, barren world. Sounds pretty bleak, I know. But given what we know about Mars's history, with a little tweaking, we might be able to bring that atmosphere back. Basically, we need to start a massive global warming effect, something that humans seem pretty good at. And scientists have come up with 3 main ways to do it. The first and easiest way might be to just build factories that would basically turn carbon, fluorine, and sulfur in the Martian soil into greenhouse gases and pump them into the atmosphere. This would unlock one of Mars's greatest assets when it comes to warming things up, the thick layer of dry ice or frozen carbon dioxide that covers its south pole. An initial burst of greenhouse gases could cause this ice to sublime directly into vapor, releasing carbon dioxide gas that would help trap more heat from the sun, in turn releasing more greenhouse gases. But all that would take a while, and it would be tough to supply those factories with the resources they'd need. So another method might be to build giant 200-kilometer-wide mirrors in space. They'd reflect sunlight onto the Martian ice caps, raising the surface temperature and releasing that carbon dioxide. If neither of those ideas worked, there's always the possibility of bombarding the planet with asteroids. In this scenario, we'd capture asteroids on the edge of the solar system and use rocket engines to propel them into Mars. The ammonia in the asteroids would act as a greenhouse gas. But each asteroid would be like a 70,000 megaton hydrogen bomb. So, aside from the obvious logistic problems, we'd have to do this way before humans were ready to set up shop there. And even then, once the atmosphere had some greenhouse gases in place, it would still need an ozone ozone layer, a shroud of molecular oxygen that would absorb some of the sun's dangerous ultraviolet radiation. So there would have to be yet another step, where we introduce organisms like cyanobacteria or lichens, which would help enrich the soil and release oxygen that could eventually form ozone. Once the ozone layer was in place, the final ingredient for an Earth-like atmosphere could be added: nitrogen. This could be introduced by asteroid bombardments, or bacteria could extract it from the nitrogen-bearing compounds locked in the regolith, the rock layer just above the Martian bedrock. Easy peasy. Mission accomplished, right? No, not quite. Mars would also need a way to hold on to its atmosphere and keep it from being stripped away by solar winds. Basically, it needs to get its magnetosphere back, which is the biggest problem with terraforming, because we really don't know how to do that yet. Earth has a magnetosphere, which we're pretty sure is formed by liquid metals in the core that create an electromagnetic field as they slosh around when the planet rotates. The same effect would happen on Mars if we could only figure out how to melt its core, which appears to be solid metal, not liquid. So if anyone has any suggestions on how to liquefy the middle of Mars, we're all ears. In the meantime, thanks for joining me for this episode of SciShow Space.
So one other way that we've looked at is this idea of shell worlds, and it's sort of a shortcut of terraforming. Now this involves encasing a planet in an artificial shell made of dirt, steel, and Kevlar fiber, and that would allow us to maintain the atmosphere and create an Earth environment. What's cool about this is you would have artificial light, which means you could control the heating and the cooling and the length of each day. Also, you would have our own choosing of composition, pressure, and temperature, which is obviously really important, so it could be just like on Earth. Also, the shell itself would provide UV and radiation protection. Basically, it would look something like this. We could have sort of hanging cities and the artificial lights, industry, spaceports, and one kind of cool thing is with the low gravity, we might actually be able to have human-powered flight. So, in conclusion, it's still a theory. It's definitely not like in that clip of Doctor Who where it's this ball of gas that we can hold everything in order to transform this universe, but maybe one day. And so for right now, it's definitely worth all the research. But it's going to take a really, really long time.